I mean, EPI produces images in a 20th of a second, really a snapshot. But those images are very poor in quality and very low resolution. And compared with images that had taken 5 minutes to generate, they didn't look very good at all. So one wondered, even if they were produced so quickly, what they would be useful for. The obvious thing was looking at the heart. And so that was where EPI started, as a technique for perhaps looking at the heart, the moving heart. So I got my PhD in 1981, and then within a few months was asked to give a talk in Winston-Salem in America, my first visit to America. And it was an invited talk as well, and they paid for it, even more amazing. But what really excited me was, I had some good data. I had the first real-time images on a rabbit's heart, and that was the title of my talk. So I was a little bit amazed that the previous lecturer to me said that MRI could never generate movie images of the beating heart. And of course, when I actually got up within minutes and showed the first images, that really amazed everybody. And at the end of the talk, I was besieged on the podium with people congratulating me and slapping me on the back. So it was one of the high points of my career, I must say. What we had done is, in a period of a few seconds, we'd actually produced a series of images which clearly showed the rabbit's heart beating. It was when other people were taking 5 minutes to generate an image, it was clearly a step forward. The process of patenting started in, I would say, 1979, when I was actually a new PhD student, because I came into the group and I looked at this method, echoplanar, as Peter had described it, and I said, I really don't think this method's going to work. Well, previously, the previous year or two, Ian Pikett had actually generated an image using the technique. So, not surprisingly, Peter Mansfield was rather not inclined to believe that his method didn't work when he had the evidence of this image. But the key point was the image they got was an image of a perfectly symmetric object placed in the center of the field of view. And my problem with the technique was that it uses an oscillating gradient, and in periods of negative gradient, you would expect the image to be the mirror image of what it should be. Of course, when the object is perfectly symmetrical, the mirror image is still correct. And so that was why the image worked, because the object was symmetrical. And the subject of the patent was fixing that problem by generating additional data in a second pass, and you splice together these two sets of data. And you did it in a very rapid way. The first set of data was obtained with a 45-degree pulse, and then immediately the second part of the data was acquired with a 90-degree pulse. And so they had an equal signal intensity, and you could put them together to generate an image. So that was really the modification to make the technique work. And after I'd convinced Peter that that indeed was the problem with the technique, we had to patent it because the previous method was not operational.